Okay, so question 10. Ethanol, molar mass equal to 46, is mixed with methanol. Molar mass is 32. To make an ideal solution at a given temperature, 5 grams of ethanol and methanol are mixed. What is the resulting vapor pressure of the resulting solution? And they also included the vapor pressures of pure ethanol and pure methanol. Okay, so this helps us to answer the question. So let's do it step by step. So step 1 is to find the number of moles of ethanol, which I'll call ETOH, and methanol I'll denote as MEOH. Okay, so the equation for number of moles is mass over molar mass. So good thing they already gave us the molar masses in the question. So we can just say that the number of moles of ethanol, both of them were 5 grams. So it's going to be 5 grams divided by its molar mass, which is 46 grams per mole, which is equal to 0.11. So now let's do the same thing for methanol. Number of moles of MEOH is 5 grams divided by 32 grams per mole, which gives us 0.16. Okay, so we found the number of moles for both. So step 2 is to find the mole fractions for both. So when we calculate the mole fraction, this is equal to the number of moles of that compound divided by the total number of moles. So first let's do it for ethanol. We calculated its number of moles to be 0.11. And to find the total moles, it's just the sum of the two solutions. So 0.11 plus 0.16. So the mole fraction of ethanol is 0.41. So now we can do the same thing for methanol. So 0.16 moles divided by the total number of moles. So if we just add it up, it's 0.27 moles. And we end up with 0.59. So another way to calculate the mole fraction of the methanol is just to do 1 minus 0.41. You'd get the same thing, but I just wanted to show all the steps. So now I have the two mole fractions. So step 3 is to determine the partial pressures. Of both of them. So to calculate the partial pressures of gases, this is our mole fraction multiplied by the vapor pressure of the pure substance. So I'm just going to write the general equation. So the mole fraction times the vapor pressure of the pure substance. Okay, so now let's find the partial pressure of ethanol first. Its mole fraction is 0.41. And its its vapor pressure of the pure substance is 44.5 millimeters of mercury. So if I multiply the two, I end up with 18.25 millimeters of mercury. And now let's do the same thing for methanol. So for methanol, the mole fraction was 0.59, and its vapor pressure of pure methanol is 88.7 millimeters of mercury. So if we multiply the two, we end up with 52.3 millimeters of mercury. Okay, so finally step 4 is to use Dalton's law to find the resulting vapor pressure. Okay, so the equation for Dalton's law is that P total is equal to the partial pressure of ethanol plus the partial pressure of methanol. So it's pretty much adding the two values that we got from the previous step. So 18.25 plus 52.3 gives us a total value of 70.575 millimeters of mercury. So this is our final answer. So now let's see what the junior tutor said. So according to Dalton's law of partial pressure, the vapor pressure exerted by a mixture of gases is equal to the sum of the partial pressures of the gases involved. So P total is equal to PA plus PB plus etc. The partial pressure of the gases can be computed by multiplying the mole fraction of the gas with its vapor pressure if it were pure. So then they showed the partial pressure is equal to the mole fraction times the pure substance's vapor pressure. So step 1 is to determine the moles of ethanol and methanol. So they got 0.11 and 0.16. Step 2, determine the mole fraction. So 0.41 and 0.59. Step 3 is to determine the partial pressures of ethanol and methanol. So they got 18.25 and 52.33. And then lastly, add the two partial pressures to determine the pressure exerted by the resulting mixture. So they got 70.58 millimeters of mercury. Yep, so that's what I got as well. So this solution is correct.